The birth of Earth, 4.5 to 3.8 billion years ago. To tell the story of life, we have to begin with the story of the world itself. 4.5 billion years ago, there was no blue planet circling the sun. There was no ocean, no sky, no land. There was only a swirling cloud of gas and dust floating in the emptiness of space. From this cloud, our solar system was born. Gravity pulled particles together, forming a disk that spun faster and faster, heating until nuclear fusion ignited at its center. The sun burst into life, and around it, clumps of rock, ice, and gas began to form into planets. Among these newborn worlds was Earth. At first it was small, violent, and unstable. Asteroids crashed into it daily, pounding its surface with craters and heat. Volcanoes erupted constantly, spewing toxic gases like methane, hydrogen sulfide, and carbon dioxide. The Earth's earliest atmosphere was harsh and unbreathable, a choking haze of chemicals that bore no resemblance to the air we know today. Yet this chaos was part of creation, the raw process of forging a planet. Not long after Earth began to take shape, something extraordinary happened. An event so violent, it nearly destroyed our world, but instead gave it one of its defining features. A Mars-sized planet, known as Theia, slammed into Earth in a titanic collision. The impact melted huge portions of the crust, vaporized rock, and blasted debris into orbit. For a time, Earth was a glowing, molten sphere, wrapped in a fiery halo of rock and dust. From that debris, gravity sculpted a companion, the Moon. That ancient collision left scars still visible in our planet's tilted axis and stable orbit, and it gave us a satellite that would forever shape tides, climates, and the rhythm of life itself. In these early days, Earth was hot and hostile. The young sun burned brighter than it does now, and with no protective ozone, radiation flooded the surface. Oceans did not yet exist. Water existed only as vapor, trapped in the atmosphere. But over millions of years, the surface cooled. Rain fell for the first time, and it fell for centuries. Drop by drop, oceans gathered, filling basins and valleys, until Earth transformed into a water world. Around 3.8 billion years ago, our planet wore oceans like a shimmering blue cloak. And in those waters, something remarkable began to stir. Water is more than just a liquid. It is a solvent, a cradle for chemistry, a medium in which molecules meet, combine, and evolve. On this early Earth, energy came from lightning, from ultraviolet sunlight, and from volcanic vents that belched minerals into the seas. In this chemical soup, simple molecules assembled into complex structures, and eventually, the first self-replicating molecules appeared. These were the seeds of life. By 3.7 billion years ago, the earliest forms of life were already present. They were not animals or plants, not even algae as we know them. They were microbes, tiny single-celled organisms clinging to survival in a world still hostile and violent. Yet, their presence marked a turning point. The Earth was no longer just rock and water. It was alive. These microbes left their mark. In places like Western Australia, fossilized microbial mats, known as stromatolites, still stand today. Layered towers of bacteria that once dominated shallow seas. They remind us that even the smallest forms of life can leave behind structures that endure for billions of years. But life's journey was only just beginning. For nearly 1 billion years after its first appearance, it would remain simple, microscopic, and fragile. It would face an unstable planet, constant asteroid bombardments, and the threat of extinction before it had even begun. And yet, despite every challenge, life endured. It adapted. It survived. The birth of Earth was violent, The birth of life was fragile. Yet from fire and water, from rock and chemistry, our planet transformed into something new, a living world. And in that transformation lay the foundation for everything to come. The continents, the atmosphere, the animals, the forests, and eventually, us. The birth of Earth, 4.5 to 3.8 billion years ago. To tell the story of life, we have to begin with the story of the world itself. 4.5 billion years ago, there was no blue planet circling the sun. There was no ocean, no sky, no land. There was only a swirling cloud of gas and dust floating in the emptiness of space. From this cloud, our solar system was born. Gravity pulled particles together, forming a disk that spun faster and faster, heating until nuclear fusion ignited at its center. The sun burst into life, and around it, clumps of rock, ice, and gas began to form into planets. Among these newborn worlds was Earth. At first it was small, violent, and unstable. Asteroids crashed into it daily, pounding its surface with craters and heat. Volcanoes erupted constantly, spewing toxic gases like methane, hydrogen sulfide, and carbon dioxide. The Earth's earliest atmosphere was harsh and unbreathable, a choking haze of chemicals that bore no resemblance to the air we know today. Yet this chaos was part of creation, the raw process of forging a planet. Not long after Earth began to take shape, something extraordinary happened. An event so violent, it nearly destroyed our world, but instead gave it one of its defining features. A Mars-sized planet, known as Theia, slammed into Earth in a titanic collision. The impact melted huge portions of the crust, vaporized rock, and blasted debris into orbit. For a time, Earth was a glowing, molten sphere, wrapped in a fiery halo of rock and dust. From that debris, gravity sculpted a companion, the Moon. That ancient collision left scars still visible in our planet's tilted axis and stable orbit, and it gave us a satellite that would forever shape tides, climates, and the rhythm of life itself. In these early days, Earth was hot and hostile. The young sun burned brighter than it does now, and with no protective ozone, radiation flooded the surface. Oceans did not yet exist. Water existed only as vapor, trapped in the atmosphere. But over millions of years, the surface cooled. Rain fell for the first time, and it fell for centuries. Drop by drop, oceans gathered, filling basins and valleys, until Earth transformed into a water world. Around 3.8 billion years ago, our planet wore oceans like a shimmering blue cloak. And in those waters, something remarkable began to stir. Water is more than just a liquid. It is a solvent, a cradle for chemistry, a medium in which molecules meet, combine, and evolve. On this early Earth, energy came from lightning, from ultraviolet sunlight, and from volcanic vents that belched minerals into the seas. In this chemical soup, simple molecules assembled into complex structures, and eventually, the first self-replicating molecules appeared. These were the seeds of life. By 3.7 billion years ago, the earliest forms of life were already present. They were not animals or plants, not even algae as we know them. They were microbes, tiny single-celled organisms clinging to survival in a world still hostile and violent. Yet, their presence marked a turning point. The Earth was no longer just rock and water. It was alive. These microbes left their mark. In places like Western Australia, fossilized microbial mats, known as stromatolites, still stand today. Layered towers of bacteria that once dominated shallow seas. They remind us that even the smallest forms of life can leave behind structures that endure for billions of years. But life's journey was only just beginning. For nearly a billion years after its first appearance, it would remain simple, microscopic, and fragile. It would face an unstable planet, constant asteroid bombardments, and the threat of extinction before it had even begun. And yet, despite every challenge, life endured. It adapted. It survived. The birth of Earth was violent. The birth of life was fragile. Yet from fire and water, from rock and chemistry, our planet transformed into something new. A living world. And in that transformation lay the foundation for everything to come. The continents, the atmosphere, the animals, the forests, and eventually, us. Rodinia to the Cambrian explosion, 1.1,440 million years ago. By 1.1 billion years ago, Earth was dominated by the massive supercontinent known as Rodinia. It stretched across much of the globe, a colossal landmass surrounded by vast oceans. From space, Earth would have looked strikingly different than today. One giant block of rock encircled by endless blue. Rodinia's existence reshaped the planet's climate and environment. Its interior was dry and arid, while its coastlines supported shallow seas rich in microbial life. The supercontinent's sheer size influenced global weather patterns, rainfall, and even ocean circulation. For life, these changes meant both opportunities and challenges. At this time, the biosphere was still primarily microbial, but something extraordinary was happening beneath the surface. Evolution was laying the groundwork for complexity. Single-celled eukaryotes, cells with internal structures like nuclei and organelles, were becoming more common. These cells had the ability to process energy more efficiently and store more genetic information than the simple microbes before them. Over time, some eukaryotes began to form colonies. These were not yet animals or plants, but they were the first steps toward multicellularity, an innovation that would eventually transform life on Earth. Rodinia itself was not permanent. About 750 million years ago, it began to break apart. As the supercontinent fractured, new coastlines formed, creating fresh environments for life to explore. Continental drift reshaped the oceans, altering currents and climates. These changes may have triggered one of the most dramatic episodes in Earth ice history, the Snowball Earth events. During these ice ages, glaciers advanced across continents, and ice may have reached the equator. The planet became a frozen world, wrapped in white. For life, these ice ages were brutal. Oceans were capped with ice, cutting off sunlight and strangling photosynthesis. Many ecosystems collapsed, but life endured in small refuges, beneath thin spots in the ice, near volcanic vents, and in isolated pools. When the ice finally retreated, Earth emerged transformed. Nutrients released from glaciers flooded the oceans, fueling new blooms of life. Oxygen levels rose, and evolution accelerated. By around 600 million years ago, a new supercontinent called Pannotia assembled. Though short-lived, it set the stage for one of the most extraordinary chapters in Earth's history, the Cambrian explosion. Between 540 and 485 million years ago, life underwent an evolutionary burst unlike anything before. For billions of years, life had been microscopic and simple. Then, suddenly, the oceans filled with complex, multicellular animals. Creatures developed hard body parts like shells, spines, and exoskeletons. This was revolutionary. For the first time, life forms could protect themselves, hunt more effectively, and leave behind abundant fossils. The fossil record from this time reveals a bizarre menagerie of creatures. Trilobites, with their armored bodies and alien appearance, scuttled across the seafloor. Anomalocaris, a predator with spiny limbs and a circular mouth, hunted in the oceans. Worms, sponges, mollusks, and the ancestors of modern animals all appeared in this evolutionary surge. Why did the Cambrian explosion happen? Scientists point to several factors. Rising oxygen levels gave organisms the energy to grow larger and more complex. New ecosystems created by shifting continents offered opportunities for adaptation. And evolutionary innovations, like vision, sparked arms races between predators and prey. Whatever the combination, the result was a sudden leap in biodiversity. The Cambrian explosion was not just about new forms of life, it was about new ways of life. For the first time, ecosystems with multiple layers of interaction appeared. There were grazers that fed on algae, predators that hunted grazers, and scavengers that cleaned up the remains. Complex food webs began to form, laying the foundation for modern ecology. But evolution is never smooth. Around 440 million years ago, the planet faced its first major mass extinction, the Ordovician-Silurian extinction. The cause was dramatic climate change. Ice sheets expanded, sea levels dropped, and ocean temperatures shifted. Many marine species, including trilobites and brachiopods, vanished. It was the second largest extinction in Earth's history, wiping out nearly 85% of marine species. Yet even in this disaster, survivors carried life forward. During this era, another milestone unfolded. Life began to move onto land. Between 420 and 350 million years ago, the first plants appeared, small and moss-like, clinging to damp soil. Soon after, the first trees rose, creating forests that transformed the atmosphere by releasing even more oxygen. Insects followed, buzzing across these new landscapes, and eventually, the first vertebrate animals crawled out of the oceans. Earth was no longer just a water world, it was becoming a green and breathing planet. The period from Rodinia to the Cambrian explosion and beyond was one of transformation. Continents collided and broke apart, ice ages froze the globe, and life made leaps in complexity. What began as a microbial planet became a world teeming with strange, armored animals in the oceans and the first pioneers on land. Each catastrophe and recovery pushed life forward, setting the stage for the rise of forests, reptiles, and eventually the great age of dinosaurs. By 440 million years ago, Earth had endured supercontinents, global freezes, explosions of diversity, and mass extinctions. And yet, through it all, life not only survived, it thrived. Evolution had shown its hand. Life was capable of extraordinary resilience, and every challenge forced new innovations. The story was far from over. The age of Pangaea and the Great Dying, 335 to 250 million years ago. By 335 million years ago, the slow drift of Earth's tectonic plates brought together nearly all of the planet's land into one colossal supercontinent, Pangaea. From space, Earth looked like a giant blue and brown sphere, one vast continent surrounded by the endless ocean of Panthalassa. This single landmass stretched from pole to pole, reshaping climate, ecosystems, and the trajectory of life. Pangaea's interior was a world of extremes. Far from the sea, vast deserts sprawled under scorching heat. Rain rarely reached these arid regions, creating landscapes of sand dunes and salt flats. Along the coasts, however, life flourished. Swamps and forests thrived in warm, wet zones, and rivers carved through fertile lowlands. These ecosystems supported a remarkable diversity of plants and animals. Forests during this time were dominated by towering lycophytes, ferns, and horsetails, some growing over 100 feet tall. Their remains would eventually form the vast coal deposits we mine today. In these swampy forests, giant insects buzzed in the humid air. Dragonflies with wingspans over 2 feet, and millipede-like arthropods the size of cars crawled through the undergrowth. The air's high oxygen content fueled these outsized creatures, creating a world that feels both familiar and alien. Animals were diversifying as well. Amphibians, descendants of the first vertebrates to crawl onto land, spread widely. They evolved into many shapes and sizes, filling rivers, lakes, and swamps. But the true evolutionary breakthrough of this era was the rise of reptiles. Unlike amphibians, reptiles laid hard-shelled eggs that could survive outside of water. This adaptation freed them from rivers and ponds, allowing them to colonize dry inland areas. It was a small innovation with world-changing consequences. As reptiles spread, they split into different lineages. Some would eventually give rise to mammals, others to dinosaurs and birds. But in the Carboniferous and Permian periods, they were still relatively small compared to the giants that would follow. The ecosystems of Pangaea were still dominated by insects, amphibians, and forests, with reptiles only beginning to stake their claim. Pangaea's formation also had dramatic effects on Earth's oceans and climate. Ocean currents shifted, altering weather worldwide. The interior of the supercontinent became drier, deserts expanded, and ecosystems changed. This environmental stress forced species to adapt quickly. Evolution was racing ahead, producing new forms of life, but it was also setting the stage for disaster. Around 252 million years ago, Earth experienced its greatest catastrophe. The Permian Triassic extinction, often called the Great Dying. It was the deadliest mass extinction in history, wiping out more than 90% of marine species and 70% of land animals. It was an apocalypse unlike anything before or since. The exact cause remains debated, but the evidence points strongly to massive volcanic activity in Siberia. For nearly 1 million years, colossal eruptions poured lava across millions of square miles. These eruptions released vast amounts of carbon dioxide and methane, triggering runaway global warming. Oceans warmed, losing their oxygen, and many marine species suffocated. Acid rain from volcanic gases poisoned soils and destroyed forests. Methane released from melting permafrost added fuel to the fire, amplifying climate chaos. The effects cascaded across the planet. Coral reefs collapsed. Trilobites, which had survived for hundreds of millions of years, disappeared forever. Insects, once thriving in giant forms, were decimated. Entire ecosystems vanished almost overnight. On land, forests withered, and deserts spread even further. The world was reduced to a barren, desolate landscape. For millions of years after the Great Dying, life struggled to recover. Biodiversity was reduced to its lowest point in Earth's history. Ecosystems were simple, fragile, and dominated by a few hardy survivors. The future of life hung by a thread. Had extinction gone just a little further, Earth might have been left barren, but survival won out. Among the survivors were small reptiles that would eventually give rise to dinosaurs, and mammal-like reptiles that carried the seeds of our own lineage. The recovery was slow, but it was transformative. New ecosystems gradually emerged. Plants recolonized the land, and new types of animals evolved to fill vacant niches. By 240 million years ago, the stage was set for the next great chapter in Earth's history, the rise of the dinosaurs. The story of Pangaea and the Great Dying is a reminder of both fragility and resilience. A single geological event, volcanism, reshaped the planet so completely that nearly all life was lost. Yet those that endured became the foundation for everything that followed. Dinosaurs, mammals, and eventually humans owe their existence to the survivors of that ancient catastrophe. Life had faced its greatest trial. It had been nearly extinguished, but not erased. And from the ashes of the great dying, a new world would rise. Dinosaurs' reign and their end, 240 to 66 million years ago. In the aftermath of the great dying, Earth was a scarred and quiet world. Forests had thinned, oceans were nearly barren, and only a fraction of species remained. Yet slowly, recovery began. By 240 million years ago, new life was rising to fill the empty niches left by extinction. Among the small reptiles that survived the Permian catastrophe, one lineage began to diversify into remarkable forms. These would become the rulers of the next era, the dinosaurs. At first, dinosaurs were not the towering giants we imagine today. The earliest species were modest in size, agile hunters and scavengers competing with other reptiles. But over the next 20 million years, they evolved into an astonishing variety of shapes and lifestyles. Some grew enormous, becoming the largest land animals to ever walk the earth. Others became swift predators, sharp-toothed and cunning. Still others adapted to the skies or water, pushing the boundaries of evolution. The Jurassic and Cretaceous periods saw dinosaurs reach their peak. Sauropods, with long necks and massive bodies, grazed on treetops, shaking the ground as they moved in herds. Carnivores like Allosaurus and later Tyrannosaurus rex ruled the food chain with bone-crushing power. Raptors, smaller but intelligent and agile, hunted in packs with deadly precision. Triceratops, with its horns and frill, stood as a symbol of defense and resilience. And among the skies, pterosaurs soared on wingspans larger than modern planes. But dinosaurs did not rule alone. Alongside them, early mammals lived in the shadows. These small, fur-covered creatures were nocturnal, hiding from predators and feeding on insects. They were insignificant compared to the dinosaurs, but they carried within them the potential for the future. While dinosaurs dominated the days, mammals learned to thrive in the margins of night. The world during the age of dinosaurs was dramatically different than today. The supercontinent Pangaea was breaking apart, splitting into smaller continents that began to drift toward their modern positions. This shifting geography created new coastlines, seas, and climates. Lush forests stretched across the tropics. Deserts expanded in dry zones, and polar regions saw warm climates unknown today. Diversity exploded as life adapted to this changing world. Marine life thrived as well. Ichthyosaurs, dolphin-like reptiles, darted through the oceans, while plesiosaurs glided with long necks and powerful flippers. Ammonites, coiled-shelled relatives of squid, filled the seas in dazzling variety. Coral reefs flourished, and fish grew more advanced. The oceans, like the land, were teeming with giants. For nearly 170 million years, dinosaurs reigned supreme. They survived changing climates, shifting continents, and evolutionary competition. Their dominance seemed unshakable. Yet, like every empire in Earth's history, their rule would one day end in catastrophe. 66 million years ago, at the close of the Cretaceous, disaster struck. A 6-mile-wide asteroid hurtled toward Earth, slamming into the Yucatan Peninsula in modern-day Mexico. The impact released more energy than 1 billion nuclear bombs, vaporizing rock, igniting global fires, and throwing mountains of debris into the sky. Within hours, tsunamis swept coastlines. Within days, sunlight dimmed as dust choked the atmosphere. Temperatures plummeted, plants withered, and ecosystems collapsed. The extinction that followed was swift and brutal. 3 out of 4 species on Earth vanished, including every non-avian dinosaur. Pterosaurs disappeared, marine reptiles perished, and countless plants and smaller creatures were lost. It was the end of an era. The age of dinosaurs had ended in fire and darkness. But as always, survival remained. Birds, descendants of small feathered dinosaurs, endured. Crocodiles, turtles, and some amphibians made it through. Most importantly, mammals, small, adaptable, and resilient, survived the catastrophe. While the giants fell, the overlooked creatures of the night inherited the Earth. In the silence after the asteroid, the world was changed forever. Dinosaurs had ruled for nearly 170 million years, but their sudden destruction cleared the way for something new. Mammals spread rapidly, growing larger, more diverse, and more complex. The age of dinosaurs gave way to the age of mammals. And in that transformation lay the seeds of our own story. The reign of dinosaurs is one of nature's greatest epics, a tale of dominance, diversity, and sudden extinction. They were not failures of evolution. They were masters of it, surviving longer than humans have yet existed. But their end reminds us of Earth's most powerful lesson. No matter how mighty, no species is safe from extinction. The same forces that built their empire brought it crashing down, making way for the next chapter in life's grand story. The rise of humanity and future threats. 66 million years ago today. When the asteroid struck and the age of dinosaurs ended, Earth entered a new era, the Cenozoic, the age of mammals. In the silence after extinction, forests began to regrow, oceans slowly recovered, and new species emerged to fill the empty niches. Small mammals, once confined to the shadows, now had the freedom to explore new roles. Some grew larger, evolving into grazing herbivores. Others became swift predators. Within a few million years, the planet was filled with a diversity of mammals, creatures that would shape the landscapes of the future. The early Cenozoic saw the rise of strange and powerful animals. Giant flightless birds, some taller than humans, dominated as apex predators before mammals grew into that role. Mammoths and mastodons roamed in herds, grazing across plains. Saber-toothed cats stalked their prey with elongated fangs. Whales, once land-dwelling creatures, returned to the seas and became the ocean's giants. Each lineage carried the legacy of survival, proving that resilience after extinction could give rise to extraordinary new forms. Over millions of years, primates emerged. From tree-dwelling ancestors, they developed grasping hands, keen eyesight, and intelligence. Around 6 million years ago, in Africa, one branch of primates began a journey that would change the world. These were the first hominins, the ancestors of humanity. At first, they were not so different from other primates, but they walked upright, freeing their hands for tools and carrying. Over time, their brains grew larger, their social structures more complex, and their abilities more advanced. By 2 million years ago, early humans like Homo habilis and Homo erectus were shaping stone tools, hunting cooperatively, and controlling fire. Fire was revolutionary. It gave warmth, protection, and the ability to cook food, unlocking new energy sources and fueling brain growth. By 300,000 years ago, Homo sapiens, our species, had emerged. We were clever, adaptable, and restless explorers. Within tens of thousands of years, humans spread out of Africa and into every corner of the planet. They hunted, farmed, built shelters, and created societies. They painted caves, carved symbols, and told stories, leaving marks not just on stone, but on memory. The rise of agriculture about 10,000 years ago changed everything. Humans settled in fertile valleys, growing crops and domesticating animals. Villages became towns, towns became cities, and civilizations rose. With farming came surpluses. With surpluses came trade. And with trade came writing, science, and technology. Humanity had become the dominant force on Earth, reshaping landscapes, taming rivers, and even altering the atmosphere. Yet the story of humanity is not just about triumph. It is also about vulnerability. Just as past species were shaped by climate, catastrophe, and extinction, so too are we. Natural disasters still strike, from volcanic eruptions to earthquakes and asteroids. Climate shifts threaten food, water, and stability. Diseases emerge and spread, testing our resilience. Though we are powerful, we remain bound to the same fragile planet as every species before us. Today, humanity faces a challenge unlike any in the past. We are altering Earth at a pace faster than natural forces. Burning fossil fuels has raised greenhouse gas levels, warming the climate. Forests are shrinking, oceans are acidifying, and countless species are disappearing. Scientists warn that we may be entering a sixth mass extinction, this time caused not by asteroids or volcanoes, but by human activity. And yet, the story is not finished. The same intelligence that gives us the power to harm our world also gives us the ability to protect it. We have mapped DNA, built machines that reach other planets, and learned the history of our own deep past from rocks and fossils. We are the only species to look back billions of years and forward millions more. That perspective carries both responsibility and hope. The legacy of Earth's history is clear. Catastrophe and recovery are part of life's rhythm. Extinction clears the stage, but survival ensures the story continues. Every breath we take carries oxygen first made poisonous by microbes billions of years ago. Every tool we use descends from the first stones shaped by early humans. Every civilization we build stands on a foundation of survival through fire, ice, and impact. If the dinosaurs' downfall opened the path for mammals, and if the Great Dying tested life's endurance, then humanity is the next chapter. Our choices will determine whether this chapter ends in collapse or continues into a future filled with resilience and discovery. We are not separate from Earth's story. We are its latest verse. The rocks remind us of what came before. Oceans freezing solid, skies darkened by asteroids, forests burned to ash. But they also remind us that life endures. As long as there is adaptation, as long as there is survival, the story goes on. From stardust to microbes, from trilobites to dinosaurs, from fire-wielding hominins to modern humans, the Earth has carried life through unimaginable trials. And though the future is uncertain, one truth remains. Catastrophe is never the end. It is transformation. And the greatest question now is not whether life will endure. It will. The question is whether we will be part of its next great age.